All right, we're going to go ahead and go to page 2. Number 11, if we look back on page 1, it did tell us that 9 through 11 are each going to be parallelograms, so we're still dealing with parallelogram properties here. We want to find x, and x is up here with the 4x. Well, as we've seen in the other problems, the easiest way to approach this is consecutive angles are supplementary. So we could take this 42 and 70 and we can add those together and get 112. So then if we add those together to equal 180, we have 4x plus 112 is equal to 180. We go through our steps of solving for x, subtracting, we'll wind up with 68, then dividing. X will end up coming out to 17. We didn't even need that 3y or anything around the sides. Number 12 is saying find y so that the quadrilateral is a parallelogram. And we're going to go ahead, and the easiest thing to do here is notice we have opposite angles. So we're looking at y, not the x. And we know our property is opposite angles are congruent. So we set these equal to each other. 3y equals 123. Pretty easy, simple, basic algebra. Divide both sides by 3. We're going to wind up with 41. So y is going to give us 41. Number 13 through 15, we're looking at a rectangle. So now we're going to use our parallelogram properties plus our new rectangle properties. Congruent diagonals. We've got 90-degree angles. All of our angles are congruent, being that 90 degrees. So here we are going to have if WY, so we look at WY, we're looking at the diagonal right here, is 19. Then we want to know what ZX is right here. And as we know, our diagonals are congruent. So the answer would be 19. Now we're saying, okay, we're sticking with that WY is 19. Then I want to know what WT is. Well, just like a parallelogram, our diagonals are bisected. So that just means half of that 19. So we're going to wind up with our 9.5. Now we're looking at TX. So we're kind of changing some things around over here. If TX right here is 4.5, we want to know WY, the whole thing. So we need to take a look at a couple things. One thing, our diagonals are bisected, and our diagonals are congruent. So with both of these, we know this is 4.5, we know this is 4.5, and then the total diagonal of XZ is going to be 9, it's going to be twice that. But XZ is also congruent to WY because our diagonals are congruent. So we just have that 4.5 times 2, and we're going to get 9. So number 16, we have a rectangle. We don't have a picture, so we're going to draw the picture. Okay. A rectangle, GALS. Make sure that we go all the way around. We're not skipping around. We have to follow consistently. Here we have diagonals GL and AS. GL right here, change some colors up, make it a little easier to see. GL is going to be 3A plus 6. And then our other diagonal, AS, the length of this, is going to be 5A minus 18. We know that we do want to find GL, so we're going to have to substitute in after we find out what A is. Our diagonals are congruent on a rectangle, so we could set these equal to each other. We have 5A minus 18 is equal to 3A plus 6. I'm going to subtract that variable with a smaller coefficient. Get 2A minus 18 is equal to 6. Add that 18 to both sides. 2A is going to give me 24. Then we divide. A is going to come out to 12. Now we need to substitute, okay, because we actually wanted to find GL. GL, as we saw up here, was 3A plus 6. So I'm going to remove A and substitute in at 12 plus 6. 3 times 12 is 36 plus 6, giving us a total that GL is going to wind up being 42. Okay. Last one on page 2. We are now looking at a square. So we're looking at all the parallelogram properties, all the rectangle properties, and all the rhombus properties. What we see here is going to be that we have the measurement at angle AEB right here is 3x. Well, we want to find x. This is going to be a short and simple one. We've learned that your diagonals of a square are perpendicular, meaning they equal 90 degrees. So all we have to do is 3x is equal to 90. Okay, because we've got 90-degree angles. Divide by 3, another really short, simple, sweet one. X is going to be 30. All right, there's your page 2.